Rational exponents. Exponents that are rational, all that means is that you have a fraction as an exponent. So when you're solving for a variable, the goal is to get the exponent to be a positive 1. So for instance, if we are solving x squared equals 5, then we want to take the square root of each side. So we want to take the square root of both sides. And so you would get x equals the square root of 5, plus or minus. So if we are trying to get the exponent of x to equal positive 1, right now the exponent is 2, we would multiply the exponent by a 1/2. So we would multiply the exponent by 1/2, because if you have a squared exponent right now, the reciprocal 2 times 1/2 equals a positive 1. So essentially you're trying to cancel out or get rid of this squared, and if you multiply by the reciprocal, that gets the exponent to be a positive 1. So from our exponent rules, we are raising x squared to the power of 1/2. So then the square root, we could rewrite the square root of 5 is the same thing as 5 to the 1/2 power. These are the same thing. So on the left we have radical notation, and on the right we have exponential notation. So those are the two differences, radical versus exponential. So in numbers 1 through 3, we're wanting to write them as exponential notation. So the square root of 21 could be written as 21 to the 1/2 power. If we have a fifth root, then that would be the same thing as saying 15 to the 1/5 power. So the denominator changes based on whatever our root is. And number 3 could be written as 81 to the 1/3 power. And so whatever root it is what goes on our denominator. And whatever goes on our numerator is whatever the power is on the inside of the radical. In this case, it's only raised to the first power. If we wanted to go backwards, so going from exponential notation to radical notation, then I could write 30 to the 1/4 as the fourth root of 30. And number 5 could be the 7th root of 28. And for number 6, we would have the 3rd root of -5. Now we'll see some that have, instead of just having 1/3, 1/2, or having 1 as your numerator, my numerator will now be whatever is on the inside of the radical. So for instance, number 7, I could write this as the 3rd root of 5 squared. Typically when you're solving these, you'll want to find the root first and then do the exponential. So number 8, we could write this as the 3rd root of 9 to the 7th power. And for number 9, it would be the 3rd root of 2 to the 5th power. So going back to a few units ago, whenever we simplified radicals, essentially what that meant is that you wanted to find numbers that you could pull out of the radical. So if I were to think about all of the multiples of 32, we have 16 and 2, 4, 4, break that down to 2, 2, 2, and 2. And so if I were to figure out, okay, what are the pairs or what are the things that I can pull out, I can pull out the 2, 2, and the other pair of 2's. So I could rewrite the square root of 32 as I would multiply the pairs and leave the single inside the radical for square root of 2. But for number 11, in order to simplify that, instead of pulling out pairs of 2, I would pull out 3 terms. So I would need to put together, okay, what are 3 terms of 2? So I have a pair of 3s. I guess a pair of 3s doesn't make sense, but I have three 2s that I can pull out. So, and then I have 2 2s on the inside. There's not two groups of 3. I only have one group of 3. So I pull out a group of 2. So I have one group of 3s, which is a 2. It's kind of confusing to say. So I pull the 2 out, and then I leave both of these 2s on the inside. I multiply those together. So it would be 2 cube root of 4, because these 2s are on the inside. Then if I were doing the 4th root of 32, now I'm going to look for a group of 4. Okay, here is a group of 4, which leaves me with one single 2. So it would be 2 4th root of 2. That looks kind of funny. 4th root of 2. So the stuff that goes on the outside is the group of 3 and the group of 4. Like here we pulled out pairs. So what comes on the outside is I have a group of 3. So basically 2 cubed is 8. And 8 times 4 is 32. But this is 2 to the 3rd power. Here, 2 to the 4th power is 16, and 16 times 2 is 32. So I can pull out a 2 on the outside, and that leaves me with a 2 on the inside. And then 2 to the 5th power is actually all 5 of these. So I have 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2. 2 to the 5th power is actually 32. So the answer for number 13 would just be 2. And you can even check these in your calculator if you type these in. So 2 4th root of 2, 2 3rd root of 4. If you type these all in your calculator, you would actually end up getting the same decimal as if you were to type in the question into the calculator. So that's just a good way to check your answer. For these, I want to do these by hand. So it says without a calculator. So I'm going to rewrite this into radical notation. Basically, this is like saying the square root of 9 cubed. And so the easiest way to solve this is to find the square root of 9 first and then cube it. Because I can take a square root a lot easier in my head than I can doing 9 cubed. So the square root of 9 is 3. I still have to write my cubed. And 3 cubed is 3 times 3, which is 9. 9 times 3 is 27. So my final answer is 27. For number 15, we have the 4th root of 16 cubed. And so I'm going to write this as the 4th root of 16 first. Then I'm going to cube it. Well, the 4th root of 16 is 2. 2 cubed is equal to 8. How did I know that the 4th root of 16 is 2? If you were to break 16 down, you have 4, 4, 2, 2, 2, 2. So 2 times 2 times 2 times 2 equals 16. So if you need to break it down just to be sure, then you can do that as well if you're ever asked to do this without a calculator. If you have your calculator, all you do is plug this in, 16 to the 3 fourth power. For number 16, this is saying the same thing as the cube root of negative 27. If you have a cube root and it's negative, that is okay. You don't have to pull the eyes out or anything like that. We're not talking about imaginary numbers unless this were a square root. But if you had an odd root, it's okay to have a negative inside the radical. And so the answer to that is just a negative 3. I can check that. Like, how do I know that the final answer is negative? Well, negative 3 times negative 3 times negative 3. This would give me a positive 9 times a negative 3, which ends up being a final answer of a negative 27. So I can check my answer just by multiplying it back out, but my final answer would be negative 3. And then the last one we have, 4 to the 5 over 2. This would be the same thing as saying the square root of 4 to the 5th power. And so I'm going to rewrite this as the square root of 4 to the 5th power. Well, the square root of 4 is 2, and 2 to the 5th power we found out earlier was just 32. So the answer would be 32. If you were asked to do this without a calculator, that is how you would solve it. If you're doing your homework, I would highly suggest checking it in your calculator just to be sure. But my suggestion is always to do the roots first, so do the denominators first, and then do the numerator last. So then we have negative 1 to the 7 over 3. That would be the same thing as writing the cube root of negative 1 to the 7th power. Well, the cube root of negative 1, I'm going to rewrite it like this. The cube root of negative 1 is just negative 1. To the 7th power, that would still give me a negative 1. The reason why I know it's negative instead of positive is because this is an odd exponent. So if it's odd, then this stays negative. If it were even, an even exponent, then it would equal a positive 1. So since the 7th power is odd, it stays an odd answer. And then finally, we have number 19. So this would be the cube root of 125 squared. I'm going to do the cube root of 125 first. Then I'm going to square it. So the cube root of 125 is 5. The reason I know that is because 5 times 5 times 5 is like saying 25 times 5 gets me 125. So that I just know in my head. You may have to think about it a little bit, but you can always check yourself. And then 5 squared gives me 25. So 25 is my final answer.